So this lesson covers material from Unit 7-8, formulas and measurement, and we're looking at box B here, perimeter and area of composite figures. By the end of this lesson, you should be able to take a composite figure and split it into simple figures, and to be able to calculate the area and the perimeter of simple and compound figures. So first off, what is a composite figure? Well, as it says on the sheet, a composite figure is made by combining two or more simple geometric figures together. So simple geometric figures are things like squares, rectangles, circles, triangles, things that you know how to calculate the area and the perimeter of. These shapes that are listed on your formula sheet, basically. We take two or more of these simple shapes and we either add them together or subtract them from one another to get a composite figure. So what you want to be able to do is take a composite figure and break it down into simple figures. So let's look at this one on the left here. What two simple shapes have gone together to make up this composite shape? Square and a triangle. Yeah, we can, and it's often helpful just to draw a little dotted line to break this down into its simpler shapes. So this guy right here is a square. This guy over here is obviously a triangle. And we've gotten this composite shape by adding the two of them together. What about in the one over here on the right? We've got, what two shapes have we combined or used to make this composite shape? What if I put a dotted line in here like this? Okay. What's the bigger shape that you see around the outside? Yeah, we see a rectangle. Now this rectangle has had something chopped out of it. What shape has been chopped out of this rectangle? It's half a circle. So 1/2 of a circle. So we've gotten this composite shape by taking a rectangle and subtracting half of a circle from it. Okay? So we can either add the shapes together or we can subtract them. So let's take a look at how you would find the area of a composite shape. And these are some general steps to follow here. They're listed on your page. So to find the area of a composite shape, first, identify the shapes that are involved and add lines breaking it up into those simple shapes if needed. Find the areas of the individual shapes, and this is where your formula sheet comes in handy. You can look up the formulas on your page, and then add or subtract the areas to get the total area. So here's our example. We've got this little funny little shape here. All right. First off, what two shapes have been combined to make this composite shape? Oh. Yeah, we've got a rectangle in the middle. Okay, and now you said a circle here. Where's the circle? Yeah, the circle, we've taken basically two half circles. We've taken a circle, broken it in half, and put 1/2 on either end. So we've got two half circles, which are the same as a whole circle, okay, for the purposes of the area. Okay, so we've got our shapes involved. We've got them broken up by lines here. Now we want to find the areas of the individual shapes. So let's start with our formulas here. If we want to find the area of a rectangle, we know the formula is length times width. So when we look at our diagram, we need to figure out what is the length and what is the width of this rectangle that we have here in the middle of our shape. We've got 20 centimeters up at the top here. We'll say that that's the length. So we'll sub that in. What is the width of this rectangle? This gets down here like this. That's a little bit trickier. We're given this distance right here is 15. Okay? That's the radius of our half circle. if this is 15 from here out to here, then from here down to here also has to be 15, and from here up to here also has to be 15. From this point here to this point here is the diameter of our circle, and so that's twice the radius of our circle. So that means that this long side here from top to bottom has got to be 15 plus 15, or 30 centimeters. So that's going to be the width of our rectangle. So 20 times 30 gives us 600, and our units are centimeters squared. Then we move on to our circle. We want to find the area of our circle, so we look up the formula on our formula sheet, pi r squared. What are we going to use for pi? Well, we can just put in 3.14 for pi. What's the radius of this circle? Well, we've already talked about that. The radius is from the center out to the edge, and that's given to us as 15 centimeters. So put in 15 for the radius, and now we just need to punch this into our calculator. Pi times 15 squared, 706.5, and again, centimeters squared. So now we've got the areas of our two individual shapes, our rectangle and our circle. Now we want to either add or subtract them together. So we got our composite shape by adding the rectangle and the circle. So we want to find our total area by adding these two together. 600 plus 706.5 gives us a grand total of 1,306.5 centimeters squared. Okay. And that's our final answer. Okay, let's try an example here involving finding the perimeter of a composite shape. Remember, perimeter is the distance around the outside of a shape. So when we're doing perimeter, all we care about is what's on the outside of the shape that we have. Okay. So again, 3 steps I think you should follow. Identify the shapes involved, draw dotted lines if necessary. Find the length of every side, again, on the outside of the shape. We only care about what's going on the outside of our shape. And a good thing to do is add them to the diagram. Okay? By the time you're done the question, you should have every side on the outside of your shape labeled. And because perimeter is the distance around the outside of the shape, to get our total perimeter, we're going to add up the lengths of the sides, again, on the outside of our shape. So let's look at an example here. We've got this little shape here. What 2 simple shapes have gone together to make this composite shape? Cool. We've got a square and a triangle here. Well, is it a square? It's a rectangle. How do you know it's a rectangle? Yeah, we've got an 8 over here, we've got 12 down here, so they're different lengths, so it has to be a rectangle. Now, when we're doing perimeter, we don't need to find the perimeter of the triangle, the perimeter of the rectangle. We identify the shapes because sometimes that helps us with our calculations. So let's start finding the length of every side around the outside of our shape. So we've got this side here, we've got the 8. We've got this side down here, we've got the 12. This side over here is blank. What can we write in for the length of that side? How do you know? Yeah. So we write in 8 over there because those sides have to be the same length. Now when we get up here into our triangle, we don't know what this side is, and we don't know what this side is. Okay. But we know that they have to be the same length, okay? Because just from the way the diagram looks. So because those are unknown, I'm just going to call them x and x. Okay. We need to figure out what the value of x is before we can calculate the perimeter of this object. How are we going to do that? Well, the shape that we have up in the top here is a triangle. And in fact, if we take that triangle and we divide it in half, like this, we have got a right-angled triangle. So we can use Pythagorean theorem to find the length of that hypotenuse, if we know the lengths of the other two sides. Well, they tell us the length of one of them. It's 2 centimeters. We need to know the length of this side down here at the bottom. What's the length of that going to be? Is the height? Yeah. And what about this one down here at the bottom? Is it 12? Remember, the right-angled triangle, we're only looking at this little part in green here, okay? Because if we look at the whole thing, it's no longer a right triangle, so we can't use Pythagorean theorem. So what do we want there? 6, because it's half of the 12 at the bottom. The whole distance across here would be 12, so this in here is going to be 6. So let's go ahead and find the length of that side x. We're going to use Pythagorean theorem. C squared equals a squared plus b squared. C is our hypotenuse, so that's x. A, I'll put in 2 for A, and I'll put in 6 for B. So x squared, let's see. 2 squared is 4. 6 squared is 36. So x squared must equal 40. So to find x, I'm going to take the square root of 40. So I've got to punch this into my calculator, and I'm going to get 6.32. Okay. So now I could label this, if I wanted to, 6.32, 6.32. My diagram's getting a little bit cluttered here. So final step. Add up the lengths of the sides on the outside of our shape. So we want to pick a starting point right here, let's say, and just go around the outside, adding up these lengths. So I'll do this in red down here. So my perimeter is going to be, starting here, I've got an 8. Coming around, I've got a 12. So add that on. I keep coming around, I've got another 8. Whoops. I don't need a dot there, I need another plus sign. Keep coming up, I get a 6.32. Come around again, I get another 6.32. And then I'm back to my starting point again. Even though we've got this 2 in here, I got this 6 in here, I don't want to add those on because they are on the inside of the shape. So I just punch this into my calculator, and I end up with 40.64, and my units are centimeters. Okay? So find the lengths of the sides on the outside of your shape and add them all up.